Right, so let's do the coding for binary tree. So binary tree consists of basically interconnection of nodes, and these interconnections consists of parent-child relations, and every node has some value stored in it. So if we were to program for that node, we need to keep in mind that that node should be able to store a value and should be able to keep track of its children, which by the way cannot exceed 2 because it is binary. So I'll begin with class node, and the first thing that I will do inside this class is define the initialization function, which is nothing but the constructor for this class. So this constructor will take as an argument the val, which is nothing but the value for that node. So now I'll be using self keyword a lot, so I'll give a brief idea of what it is for those who do not have the idea. So basically it performs a very similar role to that of this keyword in C++ or JavaScript. What it does is it makes the variable or function a property of the object and not the property of the class. So I'll perform three operations here. I'll set the value to self.val. I'll set self.left equal to none, which is basically saying that the left child is none, so there is no child as of now, and the right child is also none as of now. Self.right is equal to none. So for clarity, what I'm going to do is I'm going to create an example, and to do that I'm going to create an object for this class. I'll create an object n for the class node, and I'll pass 1 as an argument. What will happen is when I create an object, the constructor function is called automatically. That is the initialization function. So now n is a node with no child. So let's assign some children to this node. What I will do is I'll create another object of the class node, and I'll pass the argument 2, and I'll assign it to the left child of n, and I'll do the same for right child of n. This time I'll create the node with value 3. And I'll also assign a child to the node dot left, and I'll assign the value for that node to be 4. So it will be an object of node class, and the value that it will hold is 4. So now I'll print all the node values. What I will do is I'll print first of all the root value, that is node.val. Then I'll print the value of the left child of node, that is node.left.val. Then the value of the right child of the node, that is node.right.val. And then the last node that we have on our tree, that is node.left.left.val. So I expect 1, 2, 3, 4 as an output, and what is wrong is here is that I've written node, whereas the object that I've defined is n. So I'll make all the nodes as n, and now I'll run the program. So we expect 1, 2, 3, and 4 as an output, and here it is 1, 2, 3, and 4. So we successfully designed the node class and used that to develop our tree with 4 nodes. So the way we printed the values of all the nodes on our tree, that is manually, is not feasible if the tree is of size of hundreds of nodes. So for that reason we need traversal techniques. So next up is the traversal techniques that are used to print or reach out to all the nodes of the tree.